Hi guys, let's solve the 800. Sorry, we have leveled up, right? So it is the 900 rated question. So let's solve the 900 rated question. So the question says that you are given an integer. In one move, you can select any digit and remove it. The operation cannot be performed if only one digit remains. If the resulting number contains any leading zeros, they are automatically removed. So if 329 3, this is the number, third digit is 9, so if I remove the third digit, the number becomes this. What we need to do is the minimum number of steps to get a number such that it is divisible by 25 and positive. It is guaranteed that for each integer an answer exists and there are no leading zeros, so this makes it easier. If there were leading zeros, it would have been a lot more complicated. The numbers can be from 25 to 10 to the power 18. That means there is only 1 second, so we need to find a quick solution, a fast solution. If it takes n square or some similar approach which has lots of operation, then we'll get a TLE. We need a quick approach, keep that in mind. Okay, so let's look at the examples. If this was the number, to make it divisible by 25, if it is divisible by 25, that means the last two digits will be either 50 or 75 or 00 or 25. So in this case I found a 50 here, so we need to delete these three elements, so answer is 3. In this case I found 00, so I need to delete these right two elements, so 2. So we need to make the last two digits divisible by 25, that is 0, it should be 00 or 50 or 75 or 25. This is the question. So let's begin. Let's say there is a general, I'll write a general number that contains all these digits, d6 and d7. I'll underline these places. To make it divisible by 25, last two digits must be either 00 or 25 or 50 or 75. Got it? So let us say I'll consider it arbitrarily that P1 is the first digit, like P1 is the first digit from, I'll not circle it, okay. I'll assume P1 is the first digit of a number, right? Then we need to check if in this number what is the minimum deletions, so that this either any one of these four elements becomes the last two digit. So let's say that the first index of this is P1, so P1 can be 0, 2, 5 or 7, and P1 is related to P2. That means for each P1 there is a specific P2. We cannot make any of the random connections. So that means for 0, P2 will be 0. For P1 equals to 2, P2 will be 5. For P1 5, it will be 0. Got it? So for each P1 there is a P2. I have just separated the digits because we need to find it digit wise, right? How can we find it directly? We need to find it digit wise. So I just showed you that we need to separate the digits. And what we need to do is, for each, let's say we find a P1 here, this is P1 and this is P2. So that means we find any of this P1 here at this position, at digit 3 position, and for any of that arbitrary P1 there is a specific P2. That means if there was a 2 here, if it was 2 here, P2 will be 5. Okay, that's what I'm saying. So let's say for each arbitrary P1 we find a P2 here. I'm just taking a general case, and I'm showing you how the approach will be. So P2 will be at digit 6, let's say. So for example, it can be 2 5 or 0 0 or 5 0 or 7 5. And let's say that this is the closest one we have found. Okay, all these other elements are unnecessary, not unnecessary, irrelevant. Okay, these all elements are irrelevant. We have found the smallest distance between the P1 and P2. So for this case, the number of deletions will be the distance between these two elements, because this we need to erase this so that 2 and 5 or 5 or 0 or 7 or 5 can come close, right? So we need to delete these elements in between. So let's say I assume this as the gap between two, gap plus, once I have deleted this, that means these two have come close. So it can be 2 5 or 5 0 or 7 5 or 0 0. We need this to be at the last of the number, right, to the end of the number. So we also need to delete the remaining part after the P2. We need to delete this part too, so D7. So gap plus the, let's say I call this remaining part at the end. So that is the number of deletions for this case. And what we need to find out is that what is the minimum number of deletions for a number. We are given a number, and what are the minimum number of deletions so that it is divisible by 25. So we need to minimize this deletions. So how can we find this? This was a general basic approach, and we just need to implement this. This question is easy for the logic, but it is very difficult to implement. That means it is complex and lengthy for implementation. But we'll approach it step by step. You'll get to know it as we go ahead. So that will be my approach. That I'll take a number. So this is a number. This has digit 1, digit 2, digit 3, digit 4, digit 5, digit 6, digit 7, let's say. So for 25, what I'll do, I'll transverse from right to left, because we need the element 5 and 2 to the end of the string, right, to the end of the string. That means we need it as close to the right side as possible. So we'll start searching from the right side. We'll start searching if there is a combination of 5 and 2 from the right side. So I'll start from the right side and start finding if there is a 5, because as I'm going right to left, this will also be read from right to left. So first, for case 1, this is just for 25, then finding the number 25. So I'll go from right to left, and while iterating, if I find a 5, so let's say if I find a 5 here, this number is 5. That means there is a 5 here, so I have found the right digit. The flag for finding the end of the digit, finding the end, is true. Okay, I'll iterate. Okay, let me show you step by step. For I equals to n minus 1, right, the number of digits here is 7. So the indexes will be 0, 1, 2, 3, 4, 5, 6. So I'll start from the end. So I will start from I is equal to 6. I'll check if there is a 5 here. Is there a 5 at I6? No. Is there a 5 at I5? No. Is there a 5 at I4? I have considered this as true, that I have put the 5th digit, that means the digit at index 4, as 5. So yes, I have found a 5 here. So what I'll do is, yes, I have started to find the end of the digit. I need to find a 2 now. So what I'll do is, I have found a 5 here at I is equal to 4. Then I'll start finding the number 2. Is there a number 2 at position 4, that is index 3? No. Let's say there was a 2 here. Okay, this element is 2. So is there a 2 at index 3? No, this fails, this fails, this was true, this fails. Is there a at index 2? No. Is there a 2 at index? For all this I have checked the number 5, and after finding a 5 I'll start checking the number 2 if there is a number 2 at index. Now it will be 1 at index 1. Is there a 2? Yes, there is an index. For index 1 there is a 2 present. That means I have found 5 at index 4, and after that, after finding 5, there is a 2 at index 1. So what will be the number of deletions will be this, the gap, that is 2 in this case, and the remaining digit is from the end, that means from the end to the digit 5. This is the remaining part. Okay, so this is the remaining part, that is I6 and I5. These two elements I have to delete, and the gap, that means I2 and I3, these two elements I have to delete. Got it? So that's what I'll be doing. I'll show you the approach. I also did the approach in 2 steps, not in 1 step. Okay, first let me refresh this. Okay, I have 2 approaches. The first approach was the elementary one, it was the foundational. After that I have optimized it so that it is the design is good and it is the optimized way. So as you can see, this is a long code. Okay, this is not optimized, this is a very brute force method. So let's see what I have done. So for checking the number 25, as I said, I'll start from n. Here is the length of the string. I have taken it as string. Okay, so n is the length of the string, so index will be the length minus 1. So from last to the index 0, I'll start iterating. If I find a 5 here, I'll note the position. The position is denoted by variable p25. Okay, I noted this p25 and I have set the flag as true, that I have started the element, I have started to find the number 25. Once I have started, that means after finding 5, after this flag has turned true, if I find a 2, that means I have found the number 2. I'll directly count the number of deletions that I will require. So the deletions I will require is the gap. What is the gap? So if I find a 5, this is okay. If I find a 2, it is okay. But what is the gap? The gap is when I have found the number 5, and after finding the number 5, that means the flag has turned true. After the flag has turned true, if the number is not equal to 2, that means I have to increase the gap. This C25 is the gap for the number 25. So I'll start increasing the gap, and if the flag has turned true and the number is 2, that means I have reached the end of the check case. What is the check case? The check case. Okay, this is, let's say, the function. What is the check case? First I find 5, and after that, for each number that is not equal to 2, I will increase the counter, I'll increase the gap, that is in this case C25. I have denoted the variable C25, and if the number is 2, if I find number 2, if I find the number 2, then that means this was the I'll note this down. Okay, when I find the number 5, I'll note it that I have found the number 5 at the position J, at jth position, and after I find number 2, I'll also note this down that I have found it at the position I. So this will be, let's say, position I. So I found 2 at position I and 5 at position J. So what will be the formula for the deletions? Deletions will be the space in between this, that is the numbering starts from here, right? 0, 1, 2 to n minus 1. That means this will be j minus I minus 1 because this is included, right? So the gap here will be j minus I minus 1. And what will be the remaining part? The remaining part that we have to add, the remaining part that we have to add plus the remaining, right? Deletions is the gap plus the remaining part will be n minus 1. This will be n minus 1 and minus j. Let me show you clearly, okay? Let's say 0 1 2 to index n minus 1, and in between I have found I and I have found j. The position is 2 5. Let these numbers be anything, okay? So number of deletions will be to this gap in between, that is j minus I minus 1, because this j is included, right? We just need these two. So this total minus this one, so it becomes this. So it is gap, deletions will be gap plus remaining, gap will be j minus I minus 1, and the remaining part, this part will be n minus 1 minus j, right? I found it at j, so n minus 1 minus j, so n minus 1 minus j, this is 1, this is also 1. So deletion is sum of this, so sum of this will be n minus 2 minus I. Got it? And what is I? I is the position of 2. I is the position of 2. So this was the concept, and the implementation part is very complex. You have to try it on your own to even if the question is simple, the implementing part, the debugging part is very beneficial for you, okay? So I'll highly recommend you to implement this. Even if you know the concept and you have understood this code properly, you have to try this, solving this question, because implementing this is the toughest part. So I have found, if I have found 5, then I'll set the fact to true, and once it is true, if there is number 2 present, then at that position I perform the calculations, and if there is another number other than 2, that means it is the number that must be deleted. So I'll increase that in the gap. So C25 was the gap number, so I'll increase the gap. Once I find 2, I'll do the calculation. The calculation part is the minimum. Why I have put math of minimum? Because let's say, okay, this was a general approach. Now we'll say if this was a general, right, that I have found 5 and 2. If this, let's say this was 5, let's say this was 5. Once I have found 5, before I find the 2, if once I have found a 5, okay, before I find the 2, if there is another 5 present, that will be easier, right? Instead of this combo, that this 2, this 5, by pairing this 2 and this 5, it will be simpler if it was this and this, right? It is let's say it's not simpler, because what happens is that the gap decreases if there was a 5 here, okay? I'll say, okay, this is a very good thing. So it was x, 2, x, let's say there is 5 here, x, 5, x, let me write it clearly. This is a very good concept, okay? Let's understand it together. Okay, so I'll start from right to left, and once this is a pair 1, okay, the pair 1 is, I'll denote it with this, the number 2, this number 2 and this number 5, and another pair is this number 2 and this number 5. So what will be the deletion in each case? For the green case, the deletion will be the gap. What is the gap? The number between these two green elements. It is 3 plus the remaining part is 2, right? So it will be 5. Now let's see in case of the pair number 1. So deletion in this case will be the element in between is just one element, and the remaining elements are 3 elements, right? No, not 3, 4 elements. 4 elements. So answer is 5. So it doesn't matter which pair it is. Why? Because once we shift the 5, right, what we are doing is, instead of taking this 5, we are taking this 5. what we are doing is we are reducing the remaining, sorry, we are reducing the gap in between gets reduced, but what happens is that the remaining part gets increased in the same way. We are just shifting the window. Okay, got it? That means we are shifting this pointer from here to here, but the total elements, that is in between the elements and after the 5, they remain the same. Got it? So we just need to find a 5, and after finding that 5 we need to find a 2, and after finding the 2 we need to do the calculation of the number of elements in between plus number of elements at the end. That will be the number of deletions. So that is what I have done here. This is the calculation. The P25 was the position, right? You'll know you solve it on your own, you'll know the implementation, but I've told you the concept. Okay, so for 25, so for 75, for 50, for 0, I have the code gets repeated, only the value changes. Okay, the logic is same. So this was not a optimized way, right? So what I did was I made a function. This is what you guys have to do too. Okay, if you find the answer, that's not sufficient. You need to find the most optimized answer. That is what learning DSA and CP is, right? That you need to find the most optimized, elegant, cleanest way. So I'm not saying that this is the cleanest, but I am improving, right? Once I found the answer, I'm not just leaving it, I'm finding another optimized way. So what I did was I made a function which checks in us. I'll give it two strings, string 1 and string 2. It checks the number of deletions required in string 1 if I find the string 2's elements in it. That's what we are doing, right? For 25, for 50, for 75, for 00, we are finding the number of deletions once we have find the 2 elements of that 25 or 50 or 75 or 00. So this is another approach, that will make a function, and for each of these values we'll check if what is the minimum value. So for each of these 00, 75, 25 and 50, for each of these value I have passed it through the function which finds that that pair in the whole string, and the answer is the minimum of either one that is found. Okay, so this is another implementation. You can see this. You'll not understand my code. Okay, this is my approach, my implementations. Once you start doing your implementation, you'll get to know what all you did there. But I'll highly, in all of till now, this I'll only recommend this problem because this is implementation. Even if you get the logic for harder and harder question, there's no point unless and until you do the implementation. In CP, the at the end, even if your logic is correct, even if you have found the most optimized way to find the solution, unless and until you have implemented it and found and given a solution that given a submission, I meant to say. Okay, unless and until you give a so sorry, I'm getting nervous here, but what I mean to say is, unless and until you implement it, that there's no point unless and until you implement it. Okay, the end and the last thing, that is the submit button, is implementation. If you're not pressing the submit button, if you're not implementing it, there's no point in whatever you do before it. It is all waste in CP. So I'll highly recommend you, and it is necessary for you to implement this code and get an accepted solution. Okay, and once you do this, you'll get very confident that I have implemented a very complex code. So you'll get that confidence too. Okay, okay, this has been a long video, but I think you get the point why this video is long. Okay, bye, thank you guys.